Hello everyone, welcome to this video. In this video we will see the problem sort colors, or it is known as sort the array consisting of elements 0, 1 and 2. We need to sort it in constant space. So given an array of n objects colored red, it's just like story written here. So basically we have to sort the array which consists of only 0, 1 and 2. They may be duplicate 0, 1 and 2, but we need not to use the sort function of the inbuilt sort function of the programming language. So like here we are given input 2, 0, 2, 1, 1 and 0. So we need to sort it accordingly. So it will become 0, 0, 1, 1, 2, 2. So we need to use like a better algorithm because we need not to use extra space. We need to do it in constant space. So we can either like the basic solution would be like we can sort it using merge sort or quick sort or a sort function, but it is not better, or it takes n log n complexity. So we can do it in n time complexity, on time complexity. So we have two solutions basically. First one will be the three-way partitioning. It is basically known as three-way partitioning because it uses 3 pointers. So the first pointer will point to the left side, first will be the left pointer, second will be the mid pointer, and third will be the high pointer. So left pointer will keep track of zeros, the sorted way zeros, and the mid pointer will keep track of the ones, and the high pointer will keep the track of 2's in the array. So this algorithm works in this way. So first we initialize 3 pointers, that is left, mid and high. So left and mid will point to the 0th element of the array, and high will point to the n-1 element, that is in this array. For this array we have length n is equal to 6, so n will minus 1 will be 5, so h will point to 5, and the left will have zeros, and mid will have ones, and high will have 2's. Basically we are dividing the array into 4 parts, that is 0 to low, then low to middle, which will consist of the ones, and then middle to high. So it would work like that, or either you can say low to middle, middle to high, and high to n. So that is a basic idea behind this. And so these are the steps. I will try run these steps on this input, so we will see. First of all, I will explain the conditions. So we will run this code while the mid is less than the high. So mid is less than high means mid should be less than high or equal to. So if the mid will be 0, then we will swap it with the left, because left is keeping track of zeros, and we will increase or increment both the pointers, low and middle. This would be the first condition, and the second condition would be else if the mid is 1. If mid is 1, so mid is keeping track of 1 only, so we will increment the mid as it is. So the third condition would be if the mid is 2. So if it is 2, so we are keeping the track of 2 using the high pointer. So we will swap the mid and the high and decrement the high. So let's run this on this code. So we have n is equal to 5, and h will point to 5, and l and m are on 0th index. So we will check if m is here m is 2. So we will check if m is less than high. Yes, 0 is less than 5. So if m is array of m middle is equal to 0, no, it's not 0, it's 2. So else if this condition also we won't enter into this condition also, so this condition would work. So it is like we have m is equal to 0, else if like mid array of mid is equal to 2. If it is true, then we will swap the mid and the high pointer. So it is 2, yes, so we will swap this. It will become 0 and it will become 2. It will become 0 and this will become 2. So we need not to increment the mid in this. In this we need to decrement the high pointer. So high will point to this value, that is 4th index. Now we will again check for the value if mid is equal to 0. Yes, mid is equal to 0. So this condition is true. Array of mid is equal to 0. Yes. So we need to swap the low and array of low and array of mid. So we will swap this, so it will stay as it is because both are pointing to the same index. And now we will and it will be incremented now. L and M would be incremented. So this is a sorted way, this is also in sorted way. So now we will check if mid is equal to array of mid is equal to 0. Yes, it is again 0. So we will again increment low and low pointer and the mid pointer. So low will point here and mid will point here. Now mid is equal to 2. so it won't enter into this condition also and this condition also. So mid is equal to 2. So now we need to swap it with the high. So high is 1, so mid is 2. So we need to swap them both, the values of these, and it will become 2. Now we need to decrement high in this, as in this condition. So high will be decremented. Now we will check if mid is equal to 1. If mid is equal to 1, this condition won't work, and in this condition, as if array of mid is equal to 1, so it will be mid plus 1, because we need not to change the value or swap the value, because mid is keeping count of 1's in the array. So we will just increment the mid. So this condition also, we will check the condition now. While mid is less than equal to high, so yes, mid is equal to 3 and h is equal to also 3 high. So this condition, it will again enter this condition and check if which condition follows. So mid is equal, array of mid is equal to 1. So array of mid is equal to 1. This condition won't work, and in this condition mid will be incremented. So if we increment the mid, now again we will check if mid is less than equal to high. No, mid is 4 and high is 3. So this condition will end, and the output of our array will be in sorted way. So you can see array sorted 0 0 1 1 2 2, and we didn't need any extra space also. We did it in constant space using three-way partitioning method. So basically we partition the array into three like sets, like 0's, 1's and 2's. So this was first way. It takes more swaps, because if the element is 0, then and we are swapping this unnecessarily. Basically this low and mid got swapped, but it was not needed because 0 is already in sorted order. So it takes more swaps, but it is better than the our naive approach, that is sorting the array. So it takes n log n time, but it takes log n time. It takes only n time. So the third solution is counter. So we will. It is basically easy solution, easier than the three-way partitioning, and it also takes less swaps. So it is basically we keep the count of zeros, 1 and 2. We use three variables to keep the count of zeros, 1's and 2's. So we initialize three variables, c1, c0, c1, c2, and c1 will keep count of zeros, c0 will keep count of 0, c1 will keep count of 1, and c2 for 2. So we will traverse the array and make the changes accordingly. So first of all, we will traverse the array. So the array element is 2. So c2 will be incremented, it will come 1, and the next element is 0. So c0 will be incremented, next element is 2. So c2 will be incremented, and next element is 1. So c1 will be incremented, c1 will be incremented, next element is also 1. So c1 will again be incremented, next element is 0. So c0 will be incremented. So now we have count of all the zeros, 1's and 2's occurring in the array. So now we can do, like, we can traverse the array like from 1 to n. So if we traverse this array from 1 to n, now we can just override the array, like for I, if this is I, so this is I, so we can use like array I is equal to 0, while 1 is less than c0. So we will write this again. We will run a loop I 1 to c1. Then we will override the array of I as 1, and similarly we can do it for the 2 also, 1 to c2. Now we will increment. We have to write 0 here, because so now array of increment will be set to 2. So in this way we can use the counters also. So this will be easier way, because it doesn't require any swapping. Also we just need constant space to keep the count of the numbers of 0, 1 and 2. Then we can override the array using 3 for loops, which would be less than n, also n by 2 or less than that. So it will take O(n) time and O(n) space. So I will show you the code on the LeetCode platform. So this was the solution. So basically we have written a story here, like sort the colors. So you need to identify whether it matches a general problem or not. So I will show you the solution in Python. So we are given a list of numbers, and we have to increment 3 pointers, that is low is equal to 0, mid is equal to 0, high is equal to. So I am showing you the three-way partitioning way code. So here we have high is equal to length of array minus 1. So while we will run condition while mid is less than high. So if the array of mid is equal to 0, so we will swap the mid with the low. So basically this is the swapping syntax in Python. It is only just in one line we can swap the elements. So then we increment the left pointer or low pointer and the mid pointer. So if the array or element is 1, then we increment the mid, because mid is storing the ones only. So if the array else means we are left with the 2. If the array of mid is equal to 2, so this is keeping track of the 2's. So if array of m is equal to 2, so we will swap it with a high pointer. So array of mid is swapped with the array of high. So then we decrement the high. So this condition will be run till the mid is less than equal to high, and it will also check for the mid when it becomes greater than high. So this condition will fall false, so it will break. So it is basically sorting the array in place. So let's run the code and check if it's working or not. And so it is showing correct. Now we will submit the code. So you can see it is faster than 80% of the Python 3 submissions, and it got accepted. So this was the solution for how to sort an array consisting of 0's, 1's and 2's in constant space and event time complexity. Thanks for watching, guys. Do subscribe, like this video and comment down below for more programming problems. Thanks for watching, guys.